Hey folks, my name is Ravish and welcome back to another video in the series of DevOps real-time interviews. Now, we have a profile with us today. So this person is having around 3+ years of experience in DevOps and cloud-related services, but total years of experience is around 5+ years in IT. In this interview, we have concentrated only on Kubernetes and not the basic questions. We have concentrated on real-time scenarios. So we have around 10 to 15 questions in this interview. This would be around 30 plus 32 minutes video, and we have covered scenario based questions, so you can take a look at that. And almost all answers were correct, but there were a few answers in which I have helped the person, just paraphrasing whatever he is saying so that you guys are aware of the correct answer. All right, so if you're watching this video on a reel on Twitter or on Instagram or YouTube short, please do check out the pinned comment or the first comment in the comment section so that you can be directed to the real interview, which is on with the main interview on the YouTube side. All right, and if you're new over here, please do subscribe the channel because that would really support me to create more content like this. So without further ado, let's get started. Okay. So in the current project, can you just walk me through the CI/CD pipeline that you folks are doing, and what exactly you have done in that?
Yeah, in order to implement the CI/CD, we are using the tool Jenkins here. So we are using the Git flow branching strategy. In the sense, developers will create their own feature branch and they will work on the task, and the feature branch will be merged to the development branch. Whenever you want to perform the release, we used to create a new release branch on the top of the development, and that will be merged to development and master. And if you want to perform some hotfix or bug fix, we used to create a hotfix branch or bug fix branch on the top of the master, that will be merged to development and master. So in this strategy, we have two fixed branches, development and master, rest of our temporary branches. So first of all, whenever the developer checks the code to the repository, we have enabled the webhooks to trigger the job in the Jenkins. Jenkins have configured the stages like SCM checkout, compile, build, test, code coverage, code quality analysis, security scan, vulnerability scan, delivery, and deploy. These stages are configured.
Okay. So your application that you are currently working on is is written on what tech stack? Can you explain?
It's a Java-based web application, sir.
Java-based web
Yeah,
application.
architecture, it is Java-based web application. Yeah.
Okay. So have you worked on Kubernetes?
Yes, sir. I got experience on Kubernetes.
Okay. So we'll talk about the few scenarios, and let me see if you can go through
Sure.
it. So the first one would be rolling updates. Okay.
Yes.
Let's say there is a scenario in which your application is running on Kubernetes cluster. Okay.
Okay.
And you need to perform a rolling update to deploy a new version without causing the downtime. Can you explain me the steps that would be involved in this and the Kubernetes resources you would use to do that?
Yeah, first of all, in order to perform the rolling update, first we need to create the deployment YAML file. And the deployment specifies the desired state of our application. It includes the container image, replicas, all those stuff. In the YAML file, we need to mention API version, kind as a deployment, metadata. Under the spec, we need to mention the replicas, selectors, and the template. And under the spec, we need to mention the containers, which image we need to use, which port it should expose. All those information we need to pass in the YAML file, deployment.yaml file. After that, and also we need to mention the strategy. And after that, we need to apply kubectl apply -f followed by the deployment.yaml. It is going to apply. So if you want to, we need to mention the strategy there itself. With the rolling update strategy, we need to mention in the deployment.yaml itself, so that whenever if you apply the YAML file, by using that strategy, the deployment will be done.
Okay. So won't you create a newer version of your Docker image because you're going to use an image for the pods?
Yes, we need to create a Docker file, and we need to create an image from the Docker file that will be used at the time of performing the update.
Okay. Have you ever done anything related to horizontal pod scaling, auto scaling?
Yes, sir. HP I have used it. Yeah.
Okay. Let's talk about a scenario in that. So You can describe about a scenario where horizontal pod autoscaling would be beneficial, or how would you set it up using HPA in Kubernetes and configure it as per your experience.
So, so first of all, HPA horizontal pod autoscaler is a resource that will automatically scales the number of pods in a deployment replica set or the stateful set based upon the metrics what we have selected and all. So first of all, in order to enable that one, we need to enable the metric server. We need before using the HPA based upon the CPU metrics or not. We need to ensure that the Kubernetes metric server is running in our cluster, and also we need after that we need to create a horizontal pod autoscaler YAML file. So in that we need to mention API version as autoscaling, some other version kind as a horizontal pod autoscaler metadata. Under the spec we need to mention the scale target reference in that API version kind as deployment, minimum replicas, maximum replicas, metrics, which metrics it should observe. All those things we need to mention over there. Once it is done, kubectl apply -f followed by hpa.yaml file, the horizontal pod autoscaler will get updated. Then after that, we can monitor the HPA by using kubectl get HPA. And in order to view the autoscaling events, we can use the kubectl describe HPA followed by our HPA. If you give, it is going to describe. It is going. We can able to view the autoscaling events and all.
Okay.
So, yeah.
Okay.
We can use the custom metrics in order to perform this HPA so that the application will not be down.
Yeah, we can enable the metrics in the
Yes.
server so that in our cluster it shouldn't
Yes.
be.
We can define those metrics using Prometheus and some other metrics APIs and all.
Okay, okay, okay. Fair enough, fair enough. So we have a concept of persistent storage in Kubernetes.
Yes,
What
yes.
what was the purpose of persistent storage? Why do I need it?
See, persistent storage refers to the ability to store and retain the data beyond the lifetime of a single container. In the sense, it allows the data to be saved and accessed even if the pods are rescheduled or the pods are terminated or the pods move to different nodes within the cluster. The data will be there itself. So we have two things, PV and PVCs. Persistent volume is a piece of storage in the cluster which was provisioned by the administrator. Persistent volume claim is a request of the storage by the user or the application. PVCs and PVs are abstract the underlining the storage infrastructure, and they are going to allow the developers to request storage without needing to know the specifiers of the storage backend. So those things.
Okay, okay. So consider a scenario in which you have an application running and it needs persistent storage for data. Okay. Explain
Okay.
how would you set it up and use the PVs and the PVCs in Kubernetes real-time scenario.
So we need to set up from the scratch.
Uh-huh.
So in order to set up the PVs and the PVCs, first of all, we need to create, for example, we have discussed the storage class, right? We need to define the storage class, which will describe the type of storage what we want to use. And we need to write an YAML file for that. The storage class definition we need to write. In that, we need to mention the API version kind as a storage class, metadata, provisioner. We need to mention the provisioner, our storage provisioner. After that, we need to create a PVC, persistent volume claim. It is to request storage resources based upon the storage class which you define.
Okay. I'll just refine the answer. Define a we can define the first of all persistent volume with storage details. Then you need to create a PVC in which you'll specify the required storage, and
So
then
yeah,
you
we need to
attach.
create a PVC, then we need to mount the PVCs in our application, then we need to deploy our application, right?
Yeah, and then you can attach the PVC to the pod.
Yes, yes, we need to mount the PVC. Yeah.
Okay, okay. In your experience, past experience, have you ever used multi-container pods?
Yes, I have used that one. Like in the sidecar containers, I have used that one. Like multiple containers with one or more containers, two or more containers running in a single pod. For example, say we are for monitoring, we are using the log stash and all
Uh-huh.
ELK log for log analysis. The log stash agent should be run on a one container, and the main application should run on another container. Right. For that, I have used the sidecar containers, and also I have used the unit containers also, so that multiple containers will run in a single pod.
It's an example of it. So if you want logging or monitoring, just like you told with the sidecar
Yes,
container alongside with
yes,
main container, you can
yes,
deploy a
sir.
pod with two containers. One will run the
Yeah.
application and another will run the sidecar. So
Yes.
correct. Okay. So how exactly are you managing the secrets in your current project with
We
related to
use
Kubernetes?
we use the Kubernetes secrets actually. It will be store the all the information in an encrypted format. There are two things here, two concepts: config maps and the
Mm-hmm.
secrets.
Mm-hmm.
Config maps will store the data in the raw text format.
Mm-hmm.
Secret will store the data in the encrypted format by using base 64 algorithm. So we used to create a secrets file and we store the key values over there, and we used to call them in our main YAML file. We used to call those variables in the main YAML file.
Okay. Okay. Okay.
Yeah.
So are you doing the same thing for API keys and database passwords or anything different?
Database and we have the HashiCorp vault is there. HashiCorp vault.
Yeah. Okay.
In our case, we are storing most of the things in the HashiCorp vault itself, based upon the environment. So from there, we used to fetch to the Kubernetes.
Okay.
Why?
Okay.
Because here we have integrated Kubernetes, Terraform, everything with the Jenkins. So HashiCorp Vault also integrated with the Jenkins.
Uh-huh.
Jenkins is going to fetch the passwords and all from the vault.
Okay. Can you explain me any scenario where you would use a service mesh in Kubernetes?
Istio. Yeah, I have used the Istio service mesh.
Uh-huh.
Actually, Istio, it is used for the load balancing and also traffic redirecting. And
Uh-huh.
here in our case, I have used the Istio for the MTLS, mutual TLS also.
Mm-hmm.
Instead, the client certificate and the server certificate is get verified. That's mutual TLS. I have used Istio for that too. And I have used Istio for SL termination and also for the load balancing and as well as traffic routing. We have used Istio for that.
Okay, yeah, Istio is a popular service mesh, and
Yes.
you're correct about the traffic part. Traffic management, security features like TLS, which you talked about.
We can able to authenticate and authorize the users by using Istio. I have done that one.
Yes, yes, correct. Okay. Um, can you describe me a scenario where your pod security policies are essential in Kubernetes, and how would you implement them to enhance the security? Have you ever done that?
Yes, yes, yes.
Yeah. Can you explain me a scenario?
So pod security policies, those are the future in the Kubernetes, which will allow the administrator to define the set of rules for controlling the security configurations for the pod.
Mm-hmm.
We can to implement the pod securities. We can use the pod security admission controller. First of all, we need to enable the pod security admission controller. We need to write an YAML file. There, we need to mention the enable admission plugins as a pod security, and we need to mention admission controller config files. We need to give the path of that config file. So once it is ready, we need to create a PSP, pod security policy, or
Mm-hmm.
we'll call it as a constraint template. There we need to mention API version, kind as a constraint template, metadata. In the spec, we need to mention the CRD. Under the spec, we need to mention the names, kind as host path targets. We need to mention all those stuff over there. After that, we need to create a constraint, and we'll use the constraint. We'll put the constraint that will enforce to use the host path policy. Then after that, if you apply the constraints, it will work.
Okay. 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 Um, have you ever worked on this custom resource definitions, CRDs?
Yeah, this I worked on, sir.
Okay, so can you explain me a scenario where you would use CRDs in Kubernetes? You can give an example and how you created and used CRDs.
CRDs will allow us to define and use the custom resources within our Kubernetes cluster,
Mm-hmm.
and they will help to extend the Kubernetes API and create the custom objects to our specific applications and all. So CRDs we have used it for operations and controllers. Like we are using in the combination with the custom controllers,
Mm-hmm.
and operators are the software components that will automate the deployment, management, and scaling of the complex applications. We are used the yeah, for example, Prometheus. The
Mm-hmm.
Prometheus operator will use the CRDs to define the custom resources for managing the Prometheus instances. I use the Prometheus for. And the CRDs, CRDs can be used to implement the custom resource quotas and limits for the namespaces, so that it will allow us to control the resource consumption and more precisely than the standard Kubernetes resource quotas. I have used it for the resource quotas and limits, and also I have used it for the Prometheus operator, the CRTs.
Okay, okay, okay. Um, When would you use network policies in Kubernetes, and how do they enhance the cluster security?
Network policies. So just we are going to provide some set of rules in the we are going to define the rules and the policies for controlling and communication between the pods within the cluster, so that they will enable the fine-grained control over the network traffic.
Mm-hmm.
And in the pod selector, network policies will include a pod selector field, which will specify which pods the policy applies to and which parts the policy not applied to. We are going to mention in ingress and egress rules, and we are going to mention the names in that the namespace scope, and also the rules in the network policies are evaluated in the order. The first rule that will matches the traffic is applied, and that means the order of the rules matters. The first rule will take the highest precedence.
Mm-hmm.
The main use case was this network policies was, for example, if you want to implement some security and compliance, we can use the network policies. We can use the network policies to enforce compliance with security policies and standards. We can define the policies that will restrict the access to sensitive data or the services to authorize the pods. And also it will help in the zero trust networking. Like we can align the principles of zero trust networking, where we can assume the network traffic is untrusted by default and explicitly define the rules to permit the trusted communication. We can do that.
Okay, okay, great. Um, so in the current setup that you have in your project, so are you doing anything related to limits or resource quotas?
Yes, yes, sir.
So
We
the
have set up the limits and the resource quotas by using CRDs.
so you have set them up.
Yes.
Okay, how do you set them up?
Based upon the resources, how much resource, how much load is putting on the Kubernetes nodes. Based upon that, CRDs is going to set the resource quotas and the limits.
Okay, so like what are the factors that you take into consideration while doing it, while setting it up?
Mm, factors sounds like
You are going in
so
the
the
right
main,
direction. I mean,
yeah.
yeah.
Mainly the resource first of all, we need to check the resource requirements of the application. We need to analyze how much resource are consuming by the application. We need to understand the CPU. We need to understand the
Yes.
memory. We need to
Yes.
understand the namespace needs. After that, we need to identify the critical applications that require guaranteed resources. First of all, we need to identify this. And also, we need to identify the less critical applications. We need to consider using the resource limits that will allow them to burst when resources are available. And also, we need to consider the namespace isolation, and we need to consider capacity planning, those things under interest.
Yeah. So I'll just paraphrase it. So whenever there is a situation of ensuring the fair resource allocation and preventing resource exhaustion, we use
Yes,
these resource quotas and limits. So whenever we what we have done in our setup is we define a resource quota by checking CPU, memory, and the other resources.
yes,
Once
yes,
that is done, then we attach this resource quota to certain namespace, whatever we
yes,
have.
yes.
So yeah, that's what we have done. Okay, okay. Um, so if you remember, we talked about horizontal pod scaling
Yes,
previously.
yes.
So how would you implement horizontal pod scaling based on custom metrics, such as application-specific performance indicators? Custom. How would you do that?
So, so first of all, we need to define the custom metrics by using the monitoring tool.
Mm-hmm.
Custom metrics allow us to scale our application based upon the application specific or business specific metrics and all.
Mm-hmm.
So first we need to ensure that the metrics server deployed in our Kubernetes cluster, and the
Mm-hmm.
metric server is necessary for collecting and serving the custom metrics. If you use the custom metrics, it requires additional monitoring solutions. Like for example, we need to use Prometheus. We need to make sure that they are set up and configured correctly, and we need to implement the custom
Mm-hmm.
metric provider, which will expose our application specific metrics. That can be done by using Prometheus metrics. Custom metrics as Prometheus metrics. You can use to easily expose that one. After that, we need to deploy and configure the Kubernetes custom metrics API server. The custom
Mm-hmm.
metrics API server will provide the way to expose the custom metrics to the HPA, horizontal pod autoscaler. For
Mm-hmm.
example, consider Prometheus. We can use the Prometheus adapter for Kubernetes, which will translate Prometheus metrics into custom metrics API that
Mm-hmm.
can be used by the HPA. So, and after that, we need to, yeah. For example, if we take any custom metric, we can use the API server kind. We need to mention as a horizontal pod autoscaler, and a spec we need to mention scale, target reference, minimum replicas, maximum replicas, in the all those stuff we need to mention there. After that, if you apply the HPA configuration, kubectl apply -f followed by HPA.yaml, it will be applied.
Correct, correct. So either we can set up a new custom metrics API server, or you can use an existing one. So yeah,
Yes,
that's correct.
I have used Prometheus, so that's why I've taken the example of
Okay,
Prometheus. Yeah.
okay, great. Um, so have you ever done anything related to preemption and pod priority or something? Let me just like explain the scenario. Uh, any scenario in which we have pod priority and preemption in Kubernetes, that would be useful. And have you ever done that? If yes, then how?
Yeah, pod priority and preemption. Actually, those are the features which will allow us to define and control the priority of your pods within the cluster. So
Mm-hmm.
in our case, if we implement the quality of service,
Mm-hmm.
so it is going to differentiate by assigning the different priorities of the pods based upon their importance. We need to ensure that the pods with higher priority receive the guaranteed resources, and the pods with a lower priority may be throttled are
Hmm.
evicted in resource constraint situations. So we have implement the quality of service, and we assign the highest priority to system critical pods. For example,
Mm-hmm.
kubedns, kubeproxy, kubelet, the system critical pods, right? So
Mm-hmm.
we assign highest priority to them, and we make sure that they receive the resource and continue to function reliably. And I have in emergency scenarios, for example, whenever you need to deploy critical pods quickly, we'll
Hmm.
assign a highest priority to those parts to expedite their scheduling and allocation of the resources. I've done this one.
Okay, okay. Yeah, I mean, when we have a scenario in which we need to ensure critical workloads that get scheduled even during resource scarcity, because we cannot
Yes,
have all the resources every time, we
yes,
can set it up. We can assign the priorities to the pods. There is something
yes,
known as priority class name. So we can use that field, and then we can enable the priority and preemption feature.
yes,
So
yes,
this Kubernetes,
yeah,
we have this scheduler, right?
yes.
It'll prioritize the
Yeah,
high
in the YAML,
priority
we need to
pods.
mention priority class name field to
Yes,
assign the
exactly.
priority class to the pod, which will match to the numeric priority value.
Correct, 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 correct. Okay. So, can you differentiate between a Kubernetes job and a cron job? Any scenario that you have worked on? If not, then it's also fine.
No, both I have worked on. Actually, cron job is used for scheduling, right? Like, okay, one first will come with Kubernetes job.
Mm-hmm.
Kubernetes job and cron jobs both are resource types used for running the task or the batch process actually. So Kubernetes job is a resource which will use to run a single task to completion, and
Mm-hmm.
it is designed for short-lived and, for example, like batch processing or data migration, those kind of a task handle we can do by using the Kubernetes jobs. If a pod in a job fails, Kubernetes can be configured to automatically restart it until it succeeds. But the job itself will not restart automatically. Kubernetes job. If you
Mm-hmm.
consider the cron job, it is a resource manages the recurring task based upon the cron like syntax, which will schedule, and so it is used to run the task periodically. For example, if you want to take the backups or if you want to put some data synchronization, we are going to use the cron jobs. Cron jobs will automatically manage the scheduling and execution of the task. And unlike the regular jobs, the cron jobs are designed to be long lived when compared to the Kubernetes jobs, and continuously schedule and execute the task based upon the defined schedule. And
Yeah, correct. Just paraphrasing it. Uh, when we need to run the scheduled task at specific interval, we generally
yes, cron jobs.
use cron jobs, and then they'll ensure the task completion. Okay,
Yes.
okay. Okay, so let's talk about one more scenario, and this would be my last question for today. Uh,
Yeah.
Explain a scenario where you have used stateful sets over, I mean, you have preferred them over deployments in Kubernetes. If you have an example for it.
Database deployments.
Yeah.
Uh, for example, I have deployed the MySQL database. for MySQL, we have used a stateful application. Stateful sets are designed for managing stateful applications, for example, databases or some distribution systems and all. Pods in the stateful sets have the stable network identities, which means that they are consistently named and can be accessed using the predictable DNS names. And also, whenever you scale the stateful sets, the process is more controlled and sequential. Stateful sets are used when you have the ordered initialization requirements, or when the scaling involves adding the new replicas, the stateful are used. And stateful sets can automatically manage the PVCs, persistent volume claims, for each pod, providing the persistent storage. So that's why for the database and all, we are using the stateful sets. And deployments is a state for the stateless applications. Deployments are mainly designed for managing the stateless applications, like for example, web servers or some microservices where each replica is interchangeable. So there we can use the deployments. Deployments are mainly suited for horizontal scaling application, up or down, and they will allow us to easily scale the number of replicas to meet the demand and all. And also the pods, if you do the deployments, the pods created by the deployments will be given random names, and they may be rescheduled to different nodes during the updates or rescaling.
Okay. Yeah. Okay. So I think I have asked all the questions. There is one bonus question that I would like to ask. Let me know if
Yes.
you can crack this. So consider a scenario in which I have to run 3 replicas. Okay.
Okay.
And the replica set that I have written, the digit over there is 3. Now I do not need 3 replicas anymore. I just need one. Not one. Let's say 2. Okay. How
Okay.
many ways I can change that? Right now 3 replicas are running. When you check using the kubectl command, you would see 3 replicas are running. Okay. If
Okay.
I want to make that 2 from 3, how many ways do I know to do that?
Okay. Yeah. Without changing the YAML file, without changing the replica set, we can able to change that one.
No, you have multiple ways. You can change the
Yes,
replica set file as well. That's one
yes, sir.
way. That's one way of
That is
doing it. You can change it and save it and run it again. What is the other
yes.
way?
We can pass at the time of running the YAML file, we can pass the number of replicas as an what is that, adopt command,
Yes,
so that
that's
it
yeah.
is going to skip the replicas count in the YAML file. If you
Yeah,
mention
that's
as two,
that's one way.
adopt that work.
Correct. So we have 2 ways right now. One is
Yes,
changing in the YAML file. The other is the imperative command that you can give and can change.
yes.
Now, even after doing these 2 scenarios, these 2 things, the replicas is not coming from 3 to 2. What is wrong over here, and how will you troubleshoot it?
Yeah, I came across this situation, but let me recover.
Yeah, yeah, please.
Mm, there are things we can scale the replica set using the okay,
No, it is not happening, na. I mean, even through command or even through changing file, it's not happening. Not even going up or coming down. Nothing is happening. What is wrong over here? Where do I troubleshoot it? How do I see it? That's just a bonus question.
yeah, understood. Uh, we need to check for the errors. First of all, we need to edit or scale the replica. We need to check for the error messages or the warnings in the output logs. Then we
Mm-hmm.
need to confirm that the replica set name
Mm-hmm.
in the kubectl commands. We need to review the resource constraints also. If there are resource constraints specified in the replica set, that might be preventing the scaling. For example, if you have specified resource limits of the pods that cannot be met with the current available resources, scaling down will not be occur. So we need to check that one. We need to check the pod termination delays. Sometimes the pod will it will take some time for the pod to terminate. So we need to give that time. And also we need to check for the pod disruptions. We need to check if the replica set has a minimum ready seconds. Min ready seconds will be there, field set, which
Mm-hmm.
can delay the scaling down of the replicas. We need to check that too. And yeah, I can think of those areas.
Okay. Okay. All right. Yeah, I think I'm done.